So we've done one thing attached to the central atom, two things attached to the central atom, and three things attached. So the next thing we're gonna do is four things attached. So let me get one with styrofoam. So this was three. And now I'm gonna want a fourth guy. So the question would be, where would I put him? So you could think about, okay, these are all in the same plane. So if I want the four to be furthest apart and I try to put him in here, they're gonna kind of want to move away. So what's gonna happen is if I put him here, then it pushes this guy down and it pushes this guy here. And what is that shape? Kind of makes like a little cross, or if you're thinking about it like this, like a square, right? But we're thinking about it all in the same plane. So remember, these are three-dimensional objects. So we can actually make these to be not in the same plane. So if I want him to be further away, what I can do is I can kind of angle him up. If he's up, then this guy would want to kind of go angled down. This guy would want to angle up. And then this guy would want to angle down. So it's still the four that we had, but the two on the opposite kind of go up, and the two on this side kind of go down. Okay? So you have four, you have two up, two down. You kind of have them like if you had two arms like this, and then my two legs were like this. Okay? So two up, two down. Okay? This is called, because you have four, and you can actually tilt it. Okay? So let's see, let me tilt it. So if I tilt it like this, where one's completely up instead of like this, one's completely up, this shape kind of looks like a bar stool. So if you imagine a bar stool, where you're sitting, this is where your seat is, your head's here, and then you have the three legs, okay? So that's what this kind of looks like, where you have your head and your three legs, okay? So other ways you can think about this one. So there are four things attached. So the way you can remember the name is, what was our prefix for four? Our prefix for four was tetra. So if we have four electron groups, this is an AX4. It's called a tetrahedral, okay? So tetrahedral. So if I had, this is my Lewis dot structure, I'd say 1, 2, 3, 4 things are attached. So if it's four electron groups, it's tetrahedral. This is what it looks like. So this is kind of that bar stool structure. So this is where you would be sitting. These would be the legs of the bar stool in your head. But why do we call it a tetrahedral? It actually kind of makes kind of like a pyramid shape, and I'll show you that on the next slide. But let's talk about the bond angle. This one's a little funky for the bond angle. The bond angle ends up being 109.5 degrees. So you just have to remember that that one's the funky one, okay? And the 0.5 matters, so 109.5. Here's my balloon picture. So if I tied four balloons together, this is what it looks like. But the way we get tetrahedral is because this is a tetrahedron, okay? And so this is the shape. Kind of looks like a pyramid, but not exactly right. So this would be your central atom is in the middle of your shape, and then you have 1, 2, 3, and 4 things attached. And so that's how you kind of get this shape, because you have this tie on the top here, and then the three coming out at you, okay? So that would be my tetrahedral geometry. And then here's just another picture of it. If I have four things attached, and then my carbon would be in the center, and then my four bar stool legs. My three bar stool legs, and then kind of like my little head. All right, so the next one we want to do, this is 4, so let's do 5. So you might say, okay, well, if I need to do a fifth one, let me get another styrofoam ball. So if I want to add a fifth one, where would I add it? So if this is my shape, kind of like if this is my shape, you almost kind of want to think about going underneath. So if I wanted to go underneath, kind of complete opposite of where the head is, I would go underneath like this. Hold on, there we go. And go underneath like this, right? But then these that are angled down are kind of close. So what happens is these are gonna kind of go back up to not being angled down anymore. So it's gonna end up looking like this shape, okay? One on the top, one on the bottom, and then three like this. If you look at it like this, you have one on the top, one on the bottom, and then these are the three, okay? So let's think about what these three make. This shape looks like a triangle. Boop, 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 and boop. This is kind of in the middle, okay? So what this is if you think about this is the base of the triangle with the top, and then on the other side is the base of the triangle on the top. So take two pyramids, and stick them together. You have a pyramid on top and a pyramid on bottom. So what this is called is you have a triangle base. So that's where we get the name trigonal, but there's a pyramid on top and a pyramid on bottom. So it's trigonal for the base, trigonal by pyramidal, okay? So this is if I have 5 electron groups. So this is my AX5, 5 electron groups. And this is called trigonal bipyramidal. Okay? Now, you have positions above and below. So you have positions that are at the top of the pyramid and the bottom, not within this triangle. Okay? So on the top and the bottom. These are on an axis. So these are called axial. And then the positions here, these positions that are in the same plane, they're on level. Think about like if I'm talking about the globe, the equator goes from left to right. So these are kind of like in the equator line going around my molecule. So these are in the equatorial position. So it looks like equator, equatorial position. All right, so let's talk about the bond angles. So first we want to talk about the bond angle between my equatorial positions. I just took it and twisted it down. So this is the triangle, right? So what did we say? It's the same thing as trigonal planar, this triangle. So between one equatorial to an equatorial is the same as trigonal planar, which was 120. So equatorial to equatorial is 120. Okay? If I flip it back up, the top to this equatorial, axial to equatorial, makes, what does it look like? Doop, doop. This is a 90 degree. Okay? So let's look here. So we have my balloon structure. So if I put them all together, you have the 3 in the same plane, one on top, one on bottom. So between the same plane, these 3, this is 120, and from top to bottom is 90. This is axial, axial, equatorial, 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 okay? So the trigonal bipyramidal, you have a triangle, you have a pyramid on top and a pyramid on bottom. Bi means 2, so 2 pyramids with a triangle base. So my center is right here in the middle of the triangle. You've got the 3, one above, one below. That's how you get your 5 for this shape. So let's say you drew the Lewis structure. So here's my Lewis dot structure. I would say there's 1, 2, 3, 4, 5 things. So if there's 5 things, then that's going to be my trigonal bipyramidal. So this is how I would draw it in a 3D structure. 1 chlorine, this is my equatorial, axial, axial, equatorial, equatorial is 120, axial to equatorial is 90, okay? And here's just another picture for you to see it. It's kind of another model so that you can see these 3 are in the same plane. This is your equatorial, axial, and axial, okay? See this nice, pretty 90 degrees. And this is your space filling model. So you can see that central atom a little bit depending on how it's turned, but not a ton. All right, so let's do the last one, okay? So the most we can have is 6 things. So now I need to add one more compound. So on the next video, I'm gonna add that last element.